Hi, today we are going to talk about white holes. What they are, how they look like, when were they found, how do they originate and what's the evidence. But before that, if you are new to the channel, I would encourage you to subscribe and press the bell icon for further update. Welcome back to Thought Control. White holes were long thought to be a figment of general relativity born from the same equation as their collapsed star brother, black holes. However, some theorists have recently been asking whether these twin vertices of space-time may be two sides of the same coin.
To a spaceship crew watching from afar, a white hole looks exactly like a black hole. It has mass, it might spin. A ring of dust and gas could gather around the event horizon, the bubble boundary that separates the object from the rest of the universe. But if they kept watching, the crew might witness an event impossible for a black hole, a bletch. It's only in the moment when things come out that you can say, "Oh, this is white hole," said Carlo, a theoretical physicist at the Centre de Physique Théorique in France. Physicists describe a white hole as a black hole's time reversal, kinda like a video of a black hole played backwards, much as a bouncing ball is the time reversal of a falling ball. While a black hole's event origin is a sphere of no return, a white hole's event origin is a boundary of no admission, space-time's most exclusive club. No spacecraft will ever reach the region's edge.
Objects inside a white hole can leave and interact with outside world, but since nothing can get in, the interior is cut off from the universe past. No outside event will ever affect the inside.
Einstein's field equation hit physics like a tsunami in 1915. Beyond describing the force of gravity, his hypothesis also brought a paradigm-shattering message about the nature of reality. More than a rigid backdrop, space and time bend and fold along with the mass of stars and planets. That insight sparked a race to calculate just how much abuse space could take from the matter that drifts through it. Within a year, physicist and astronomer Carl found the first exact solution to Einstein's equation, calculating how space-time curves around a single ball of mass. In his answer lay the seeds of what physicists today call a singularity, a spherical mass shrunken down to an infinitely dense point, wrapping space around it so tightly that the region pinches off from the rest of the universe. It forms a no man's land whose event origin fractures the link between cause and effect.
Black holes, the most famous singularities, are regions of space so warped that no exists out of it exists. The outside universe can influence the inside of a black hole's horizon, but the interior can't affect the exterior. It took 40 years to understand black holes, and it's only recently the people have been focusing on white holes. Rovelli said,
While general relativity describes white holes in theory, no one knows how one might actually form. A black hole cordons off its bit of space when a star collapses into a tiny volume. But playing this video backwards doesn't make physical sense. An event origin exploding into a functional star would look a bit like an egg unscrambling itself, a violation of the statistical law demanding that the universe get messier over time. Even if large white holes did form, they probably wouldn't hang around too long. Any outgoing matter would collide with the matter in orbit and the system would collapse into a black hole. A long-lived white hole, I think, is very unlikely, said Hal Haggard, a theoretical physicist at Bard College in New York. So for a while, white holes seem to share the fate of wormholes, mathematically permissible contortion of space-time like prohibited by reality. But in recent years, some physicists have brought white holes back in an attempt to save their darker siblings from an unseemly death. Ever since Stephen Hawking realized in the 1970s that black holes leak energy, physicists have debated how the entities could possibly shrivel up and die. If a black hole evaporates away, many ask, what happens to the internal record of everything it swallowed? General relativity won't let the information out and quantum mechanics forbids its deletion.
How does a black hole die? We don't know. How is a white hole formed? Maybe a white hole is the death of black hole. Rovelli said the two questions join nicely, but you have to violate the general relativity equation in the passage from one to the other.
Rovelli is a founder of a quantum loop gravity, an incomplete attempt to move beyond general relativity by describing space itself as a built from Lego-style particles, guided by tools from this framework. He and others describe a scenario where a black hole grows so small that it no longer obeys the common sense rules of stars and billiard balls. On the particle levels, quantum randomness takes over, and the black holes could transform into a white hole. Such a microgram sized white holes, being similar in mass to human hair, would have none of the gravitational drama of its black hole ancestor, according to Hegward, but would hide a cavernous interior containing the information of everything it had swallowed in its previous life. Too small to attract orbiting matter, the white hole might remain stable enough to eventually spit out all the information accumulated by its forerunner. In this picture, white holes would one day come to dominate the universe. After the stars have burnt out and the black holes have withered, any observers then could easily detect the objects as relatively large particles. But those days are countless trillions of times the current age of the universe in the future. Alternatively, the aftermath of a white hole may exist everywhere. To black hole physicists, the Big Bang's explosion of matter and energy looks like a potential white hole behavior. The geometry is very similar in the two cases, Haggard said, even to the point of being mathematically identical at times.
Cosmologists call this picture the Big Bang bounce, and some see characteristics white hole features in the universe's earliest observable light. The universe may not contort itself into all the shapes general relativity allows, but Haggard thinks physicists should follow this rabbit hole all the way to the end. Thank you so much for watching this video. If you have any feedback, please let us know in the comment section below. And do not forget to share and subscribe. Thank you. Bye bye. Hasta la vista.
बावळी बूच अरे गदा की
Okay, started. Of general relativity.